hello, welcome to Math&Me with me, Nikhila Sankar. Today we are going to deal with straight lines. Before that, I am really very happy for the overwhelming response. Do support my channel, do share it with your friends and family. Help class 11 kids score good marks in their exams. So let's get into straight lines now. So first, we are going to look at a few formulas. Okay? So first is the distance formula. So when you have 2 points, P of x1, y1 and Q of x2, y2. So if this is the point P and this is the point Q, the distance between them, the distance PQ is given as PQ is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Basically, it is the subtraction of the x coordinates and the y coordinates in the square root. The next formula is that to find the point, for example, let the point be x3 and y3. You need to find the point. Let this point, I'll denote it by R. So if this is the point R and this is the point P and this is the point Q with coordinates x1, y1 and x2, y2, and this point R separates the line segment PQ in the ratio m:n, then you can find the coordinates of R using this formula. So the coordinate of R, which is x3, y3, is nothing but mx2 plus nx1 by m plus n. This is the x coordinate. So that's why we are taking the x coordinates of the 2 points. Comma m y2 plus n y1 by m plus n. So this is how you find the coordinates of the point that divides the line segment in some specific ratio. For example, if this m and n have the same value, if m is equal to n, so that means that R is the midpoint of P and Q. So what happens when you substitute that in this formula? If m and n are equal, so that means here you have m and here you also have m, and here it becomes m plus n. So what happens? R of x3, y3 is nothing but mx2 plus mx1 divided by m plus n. I'm just replacing the n with m because they are all equal. What if they are equal? M y2 plus m y1 divided by m plus m. So what happens? When you take the m out, you have 2m in the denominator, the m gets cancelled. So what do you get? R x3, y3 is nothing but x2 plus x1 divided by 2. You have 2m, the m goes off. Similarly, y2 plus y1 divided by 2. So this is nothing but the midpoint of the line segment. Midpoint of, for example, our line segment here is PQ. This is how you denote a line segment. Do you remember all this? You have learned this in, I think, your 7th or the 8th class. So this is how you represent a line segment, and this is how you represent a line. This is how you represent a ray. So just reminding you with all this. So this is basically the midpoint of the coordinate that divides the line segment PQ into two equal halves. Here m and n, if they are not equal, that doesn't mean they are equal halves. If m is equal to n, then it means they are equal halves. Okay, so that is the midpoint. This is the third one. The fourth one is the area of a triangle. So what do we have in a triangle? We have three coordinates, P, Q and R, with coordinates x1, y1, x2, y2 and x3, y3. So the area of the triangle is half times x1, y2 minus y3 plus x2, y3 minus y1 plus x3, y1 minus y2. So how can you remember this? You have x, y, y and the subscripts are 1, 2, 3, 2, 3, 1, 3, 1, 2. It is basically a cyclic one. So when you have 1, 2, 3, it will only go around. So you have 1, 2, 3, 1, 2, 3. You have 2, 3, 1, 2, 3, 1, and you have 3, 1, 2, 3, 1, 2. This is how you can easily remember the area of a triangle formula. Okay. So these are all the 4 consolidated formulas, and we'll see some examples using these formulas. Okay. Next is the slope of a line. What do you mean by a slope? So when you have a line that passes through the x-axis, the angle that it makes with the x-axis is the theta. And the slope or the gradient, we also call it the gradient, is nothing but tan theta. Okay, so tan theta is nothing but when you have 2 coordinates. For example, this is your point P and this is your point Q. And if this has coordinates x1, y1 and this has coordinates x2, y2, that means that tan theta is nothing but y2 minus y1 divided by x2 minus x1. This is the slope of a particular line or a line segment. A line segment can also be extended further, right? It is also a line. So basically the slope of a line or a line segment, or which is also called the gradient, is tan theta, which is y2 minus y1 divided by x2 minus x1. So this is when theta is acute. Do you see what is an acute angle? When the angle is less than 90 degree. When the angle is between 0 and 90 degree, it is a acute angle. What if the theta is an obtuse angle? So this is when theta is acute. So what if when theta is obtuse? When you have a line segment like this, so the angle made by the line segment with the x-axis is an obtuse angle. So here you have the point Q, here you have the point P. So what does your slope become? Tan theta is nothing but, similarly, y2 minus y1 divided by x2 minus x1, but just with a minus sign. Why do you have a minus sign? Here, if this becomes the right angled triangle, so you have tan theta, which has the coordinates of P and Q. But here, the right angle is over here. So you need to know what this angle is. If this angle is theta, what is this angle? It is 180 degree minus theta. So basically, here your tan theta is not just tan theta, but it is tan of 180 minus theta. Tan 180 minus theta, which is the slope in this case. What is tan 180 minus theta? You know this is the first quadrant, second quadrant, third and the fourth quadrant. All silver tea cups. So in this particular quadrant, tan is positive. So that means you have 180 minus theta. 180 line is over here. 180 minus theta meaning the particular angle lies in the second quadrant. Here tan theta is not positive. So when tan of 180 minus theta is nothing but minus tan theta, which is y2 minus y1 divided by x2 minus x1. So tan theta is nothing but minus of y2 minus y1 divided by x2 minus x1. So basically when theta is acute, you have tan theta equals y2 minus y1 divided by x2 minus x1. When you have an obtuse angle, when theta is obtuse, you have minus tan theta equals y2 minus y1 divided by x2 minus x1. Okay? Okay. What do you have when you have 2 parallel lines? So for example, in this particular graph, when you have 2 lines, say L1 and L2, when you have 2 parallel lines, denote one angle by alpha, denote the other angle by beta. So the slope of the first line is tan alpha, let us name it as M1. The slope of the second line is tan beta and let us name it as M2. So when 2 lines are parallel, it means that their slopes are equal, meaning M1 is equal to M2. So tan alpha is equal to tan beta. How do you know that? Why is tan alpha equal to tan beta? You know that when 2 lines are parallel, the angle made by them, these are all the corresponding angles. So ultimately alpha is equal to beta. They make the same angle. When they make the same angle, the tan theta is also the same, which means that the slopes are equal. So when you have parallel lines, it means that M1 is equal to M2. It's very important. Next comes the perpendicularity. So when you have perpendicular lines, Meaning, when you have a graph and you have two lines that make 90 degree with each other. So this is the 90 degree angle. So this is line 1 and this is line 2. So let us assume that this angle is alpha and this angle is beta. So what do you have? These are two intersecting lines. So vertically opposite angles are equal. So this particular angle will also become 90 degree. What do you know about triangles? Sum of the interior angles of a triangle is equal to the exterior angle of a triangle. So that means alpha plus 90 degree is equal to beta. Taking tan on both sides, what do you have? Tan of alpha plus 90 is equal to tan beta. Tan of alpha plus 90 is nothing but when you have this 90 plus alpha is over here. It is in the second quadrant. All silver tea cups. Means the tan of alpha plus 90 will be negative. Also since it's 90, it will be minus cot alpha equals tan beta. What is cot alpha? Minus 1 by tan alpha equals tan beta. What is tan alpha? We have tan alpha is m1 and tan beta is m2. So minus 1 by m1 equals m2. So what is your final relation? m1 m2 equals minus 1. So this is another thing that you need to remember. When two lines are perpendicular, you have the product of their slopes to be minus 1. When you have two parallel lines, the slopes are equal. Okay, so this is what you need to remember to solve all your examples and exercise questions. It is very, very useful.